Welcome back to the deep dive. If you, like us, have been tracking the tectonic plates shifting beneath the military world,
The big shift.
a huge one, the big pivot away from the, let's say, comfort of counterinsurgency or coin and toward the brutal reality of high-intensity peer conflict.
Right.
That what worked yesterday is, well, it's a strategic liability today. We've been handed this monumental stack of source material.
It's quite a stack.
White papers detailing a pretty radical, but they argue necessary, proposal to redefine how the Air Force and the Army actually fight together, specifically, along a highly contested front like the Eastern Flank or in the Indo-Pacific.
And this is more than just some procedural tweak. It's a fundamental break from 2 decades of ingrained operational habit.
Of muscle memory.
Exactly. The mission for us today is to really deep dive into why our current, comfortable way of delivering air support, a system that was optimized for conflicts where we, frankly, guaranteed air superiority, is now, in a contested fight, the single greatest threat to our operational tempo, and maybe even our survival.
So we're talking about a complete restructuring.
A complete restructuring of joint fires.
Yeah.
Transforming it from what is now a slow, kind of service-specific model into a rapid, almost machine-driven architecture.
Okay, let's unpack this and get right to the core of the problem statement laid out in these sources. The authors, they define the current situation as a function of the muscle memory of counterinsurgency. They state that air-land integration is optimized for what they call high-friction close air support, or CAS. For those listening who might only know CAS from the headlines, can you define that friction for us? What does that process actually look like on the ground?
That phrase, high friction, it captures the inherent latency and the risk perfectly.
Yeah.
So close air support is defined as air action against hostile targets that are in close proximity to friendly forces.
Right. Danger close.
Danger close, exactly. And because of that proximity, we could be talking hundreds of meters or even less. It requires detailed integration.
And that's the friction.
That detail is the friction. It means you have to have a highly specialized human on the ground, usually a Joint Terminal Attack Controller, a JTAC.
The best of the best.
The absolute gold standard, coordinating meticulously, step by step, with a manned aircraft pilot, making sure that multi-million-dollar munition doesn't land on their own troops.
And that complex step-by-step process, it worked. It worked beautifully when we had the luxury of time and, totally uncontested air.
Absolutely. But now it's the primary enemy of achieving the kind of speed you need on a modern battlefield.
And this brings us right to what the sources call the strategic liability. They're very, very clear on this. Our fixation on this CA stance, where a high-value pilot is basically holding a ground controller's hand, is a critical weakness when you're facing a peer competitor, somebody with real integrated air defenses. So why?
It's a fundamental resource mismatch. That detailed integration forces the Joint Force Air Component Commander, the JFACC, who's the operational commander in charge of all air assets in the theater.
The air boss.
The air boss, yeah. It forces them to fly their most valuable, survivable, and often their manned platforms. Think F-35s, Growlers, advanced fourth-gen fighters, directly into a very near contested airspace.
So you're putting your queen on the front line.
You're putting your queen right in the line of fire. These assets, which are priceless in terms of cost, pilot training, they're forced to loiter, to just circle around and wait for human coordination, waiting for that final cleared hot call from the ground.
So they're just sitting ducks exposed to the threat rings, the enemy's surface-to-air missiles, for way longer than they need to be.
Precisely. They're consuming incredibly expensive fuel, they're burning through engine cycles, and they are exposing irreplaceable human capital, our pilots. All while they're waiting for a coordination process that takes minutes in a fight where success is measured in seconds.
And the result, as documented over and over in these sources and recent wargame reports, is that the effects delivered are, and this is a direct quote, too little, too late.
Too little, too late. We are using a scalpel, and we're using it slowly, when what we really need is a high-speed wrecking ball. The air component is operating at a tempo dictated by human dialogue, not by the machine's actual capability.
So if the CAS model, our 2 decades of muscle memory, is the liability, what's the countermeasure? The mission overview here focuses on bringing back and fundamentally modernizing a historical concept, Battlefield Air Interdiction, or BAI.
This is a massive intellectual pivot, a huge one.
Explain that pivot.
It is the shift from reaction to prevention. Interdiction, at its core, is about destroying or delaying the enemy's potential before it can ever be brought to bear against your own ground forces.
So instead of a rescue mission.
Exactly. Instead of relying on a last-minute rescue mission, which is what CAS often is, the doctrine shifts to ensuring the enemy's main body is decimated, or at least disorganized, long before they can even reach your forward line.
And the central defining innovation proposed to make this happen is a, frankly, radical simplification of the battle space.
It is.
The creation of a 30-kilometer autonomous zone forward of the forward line of owned troops, the FLOT. It's a very specific distance.
And that zone is the key. It's the key to unlocking speed. It is a dedicated, machine-operated killing zone.
So the goal of this doctrinal shift is pretty simple then.
It's to transform the entire joint fires relationship. We shift completely away from the current permission-seeking CAS architecture.
Where you're always asking, "Mother, may I?"
Yes, exactly. Where every single bomb requires detailed, multi-step human verification. We move from that to an execution-focused interdiction model. In this new zone, the machine's default state is fire. The default state is tempo.
Okay, to structure this new fight, we need to understand the new rules of the road. They are establishing a hard line using existing military terms, but totally redefining its function. Let's introduce the first key concept, the Battlefield Coordination Line, or BCL. What is the BCL in this new autonomous context?
Traditionally, the BCL is just one of many fire support coordination measures on a map, but here it's given this almost existential purpose. It is the hard limit for friendly human presence.
The hard limit.
This one line dictates everything. Short of that line, near your LOT, you've got your friendly ground troops, so you must use that slow, detailed CAS coordination. But beyond that line out in that 30-kilometer gap, no friendly humans.
None at all.
None. Whether they are in manned aircraft or there's some kind of ground maneuver force, they are not permitted. It is the definitive, non-negotiable boundary separating the human domain from the machine domain.
The moment you draw that line and you can guarantee that sterility, you change everything about the risk calculus.
Everything.
And that brings us to the second key concept, which governs how we spend our machine assets in that high-risk zone, actuarial risk. We are moving away from the commander's gut feeling about what's an acceptable loss.
That's the big philosophical leap. Actuarial risk is the new, quantitative, calculated logic governing the expenditure and use of uncrewed systems, which the sources term attritable assets.
Attritable, meaning you expect to lose some.
You expect to lose them. So instead of a commander subjectively marking a mission as, say, medium risk, the system uses vast amounts of real-time data to calculate a precise probability of loss. It's data-driven expenditure based on threat calculations, and it enables highly aggressive and rapid execution because the system knows its statistical budget. If the calculated risk is acceptable within the commander's pre-approved budget, the mission executes instantly.
So we have the current problem-slow CAS in contested airspace, and the proposed solution, this rapid BAI in an autonomous zone, governed by the BCL and actuarial risk.
Right.
Now, to really appreciate why this shift is so critical, we have to look back. We need to understand the historical failure that led us to this flawed reliance on CAS that we have today.
You can't fix the doctrine if you don't understand the history of how we broke it. The current push CAS model we use, it's a direct consequence of a massive failure in communication and coordination from decades ago.
So let's start with the original doctrine, Battlefield Air Interdiction, BAI. Can you revisit that definition and crucially explain its intended role within those old Cold War concepts like air-land battle?
Sure. BAI was intended to be the hammer blow, the hammer delivered by air power to destroy or delay the enemy's potential, specifically their follow-on forces, their reserve echelons, before they could ever consolidate and attack your forward units.
So hitting the second and third waves.
Exactly. In the famous air-land battle doctrine, BAI was absolutely crucial. It was designed to extend the depth of a corps commander's fires. The idea was simple. The Joint Force Land Component Commander, the JFLCC, would nominate critical targets, enemy tank concentrations, logistics hubs, command posts that were beyond the range of the Army's own organic artillery.
Like their howitzers and rockets.
Right. But these targets were still short of the main fire support coordination line, the FSCL, which defines the deepest part of the Air Force's deep strike zone. So BAI was meant to bridge that gap, that critical gap between the land commander's reach and the air commander's lethality.
It sounds, structurally perfect for a big anti-armor fight in Central Europe. You're using air power to thin the herd before it arrives.
This is a great concept.
So if the concept was so sound, what was the historical failure of BAI? Why didn't it work?
The core failure was one word: Latency.
Latency.
The concept was way ahead of the technology. I mean, try to picture the environment. An armored breakthrough in the 1980s. A ground spotter sees a massive enemy tank concentration moving at high speed, maybe 40 kilometers from the FLOT.
Okay.
That target information, the nomination, was born in an analog world. It had to be verbally or textually passed up the chain of command. First within the Army, maybe through a fire support element, then up to the Corps headquarters.
And from there, it had to jump the fence. It had to get over to the Air Force system.
Exactly. It would then be routed to the Army Air Ground System, the AGS, and eventually find its way to the Air Support Operations Center, or ASC, and then finally to the Air Operations Center, the AOC, the nerve center for the Joint Force Air Component.
And the AOC is where they build the daily flight schedule, the air tasking order, the ATO.
It's right. And the ATO is this highly detailed master schedule for all air operations, and it's usually published 12 to 24 hours in advance.
Wait a minute. So if the tank column is moving right now and the ATO was written yesterday, that creates a monumental scheduling problem.
It creates an impossible problem. You're trying to slot a time-sensitive pop-up target into this massive, bureaucratic, pre-planned ATO structure using analog communications like radio relays and, teleprinters. It meant massive delays.
So by the time the message got through,
By the time the Air Force could reasonably task an aircraft, launch it, route it, and get it on target, the window of opportunity to influence the enemy's movement had long closed. The target had either moved or, worse, it was already in close contact with friendly forces.
which means the mission just became CAS, not BAI.
Exactly. The original intent was lost.
That structural delay, that latency, it must have just eroded all trust. It sounds like the land component simply lost faith that the air component could deliver BAI effects in time.
They did.
Mm-hmm.
And that lack of confidence led directly to the compromise tactic that became the standard for the next 20, 30 years. Push CAS.
Push CS.
During the Gulf War, commanders knew the analog BAI system was just too slow, but they had all these airframes they needed to use, so they adopted the push tactic. Aircraft were launched with a primary guaranteed mission of CAS. If they arrived on the station in the battle space around the FLOT, and the ground commander said, hey, we don't have any immediate troops in contact or TIC,
Then the pilot would be pushed.
the pilot would be pushed deep to go find something to hit, to go execute interdiction instead.
So it was a flexibility measure, trying to salvage some effectiveness from these pre-planned sorties. But our sources, they identify two profound strategic costs that made this model just totally unsustainable for a peer conflict. Let's start with the first one. Flaw 1. Inefficient weaponeering.
This is a huge cost, measured in both lethality and logistics. Because that pilot launched with a guaranteed CAS mission that might put them right over friendly troops, their aircraft had to be loaded with munitions that minimize collateral damage and the risk of fratricide.
So small bombs.
Small, very precise, but lower yield, very expensive guided munitions. Things like the 500-pound GBU-12 Paveway 2 laser-guided bomb or the small-diameter GBU-38 JDAM.
These are surgical tools.
They are surgical tools, designed for hitting a specific window or a single vehicle very close to friendly forces.
I see. So they had to prioritize safety above mass destruction. And this leads right to the second flaw when they are pushed deep. Flaw 2. Using the scalpel on area targets.
You've hit on the perfect analogy. When that aircraft, which is loaded with these surgical precision weapons, gets pushed to execute an interdiction roll 50 kilometers out, they're attacking large, distributed enemy area targets.
Like what?
A massive motor pool.
Hmm.
A staging area for an entire tank battalion. A large artillery battery spread out over a field.
Yeah.
These are targets that require volume saturation. They require the sledgehammer effect.
But they're only equipped with scalpels.
Exactly. So they're forced to expend these very expensive, lower-yield precision munitions on targets that demand cheaper, higher-yield area effect bombs.
And this mismatch has a devastating twin effect on the JFAC, the air boss, today.
It does, a devastating
You
one.
under those dangers.
The first danger is the rapid and frankly unnecessary depletion of our precision magazines. We're using our most sophisticated, strategically limited bombs on targets that can be handled by much cheaper, non-precision ordnance if safety wasn't the number one constraint.
We're running out of smart bombs.
We're running out of smart bombs by using them on dumb targets. And the second, and perhaps the greatest liability, is that the entire push CAS model mandates that those high-value manned aircraft, the cornerstone of our air superiority, must loiter in high-threat rings, waiting for detailed human coordination that may or may not ever come. This reduces the overall volume, the mass of fire that JFE can deliver.
So they're flying too close, they're carrying the wrong weapons, and they're waiting too long.
That is not how a peer conflict is won.
Okay, that historical context is just crucial. The current system is slow, it's wasteful, and it puts our most valuable assets in harm's way for no good reason.
Right.
The key, then, is to solve the historical failure of latency and the contemporary problem of proximity at the same time. This brings us back to the structural solution, the operational concept of the autonomous zone.
The sources insist that to generate the necessary volume of fire and tempo against a peer threat, you need an utterly simplified, machine-readable battle space. We have to stop thinking of air-land coordination as, a negotiation.
And start thinking of it
As simple geometry.
let's visualize this. Redefining the battlespace geometry, we need to clearly delineate the three critical lines that structure this 30-kilometer autonomous zone.
Okay, think of it like a series of nested rings on a map, and each ring has a very distinct rule set.
Okay.
1. First, the innermost ring is defined by the forward line of own troops, the FLOT. That's just the simple physical location where friendly boots are on the ground.
Simple enough.
2. The outermost ring is the Fire Support Coordination Line, the FSCL. This is the traditional deep boundary, often set by the land component, to coordinate all fires in the theater. Beyond this line, the land component generally hands over complete control to the air component for deep strikes.
Okay, FLOT and FSCL, what's the third?
The third is the absolutely critical boundary, the
Yeah.
one that falls between the FLOT and the FSCL, and that is the Battlefield Coordination Line, the BCL. This is the new, non-negotiable restrictive measure, and is placed precisely 30 kilometers forward of the FLOT.
Okay, why 30 kilometers specifically? Is there a doctrinal or technological reason for that specific distance?
Yes, and it's a great question. That 30 kilometers distance is very strategically chosen to maximize the zone's efficacy. It generally correlates with the maximum effective range of a significant portion of the land component's own organic fires, particularly their artillery systems.
So they're rockets and cannons.
Their rockets are cannons, exactly. By pushing the BCL out to 30 kilometers, we ensure the land component can still effectively engage targets short of that line using their own assets, while at the same time giving the air component enough depth to operate interdiction fires without worrying about fratricide from those friendly ground systems.
Ah, I see. It's the necessary standoff distance that creates safety for both the human maneuver on the ground and the massive machine fires in the air.
Precisely.
So the BCL is the surgical cut that creates two distinctly different operational environments. It clearly delineates the human versus machine domains. What are the hard rules for the human domain, short of the BCL?
Short of the BCL is the realm of the human warfighter. Friendly ground forces are maneuvering there. They're potentially in contact with the enemy. Therefore, this area demands that slow, high-friction, detailed CAS integration we talked about.
Safety first.
Safety is the priority. Tempo is secondary, no question.
And then the new territory. Beyond the BCL, that crucial 30 kilometers autonomous zone.
This space is sterilized. The sources emphasize this over and over. No friendly humans, whether they're in manned aircraft or they're ground scouts, are permitted to enter this 30-kilometer volume. That physical separation is the entire foundation of the new tempo. If a friendly human crosses the BCL, the machine fires in that sector stop immediately.
So you sacrifice tempo for safety.
You have to. The rule must be non-negotiable to maintain the system's incredible speed.
This sterilized zone, the volume between the BCL and the FSCL, is then designated to function as a permanent purple kill box. That sounds highly permissive.
It's as permissive as it gets. A kill box is a fire coordination measure where fires can be placed without detailed coordination between services. The term purple means that both the Army, the land component, and the Air Force, the air component, have the authority to deliver fires into that space.
So by making this area a permanent and purple kill box,
You achieve instant authorization for fires.
and the most important element of that permissive nature is the removal of the human gatekeeper. Since you've guaranteed no friendly humans are inside, the requirement for cleared hot from a JTAC or a FACA is entirely removed.
That is the crucial latency killer. That's the whole point. The safety requirement is removed by the lack of friendly exposure. This means the system doesn't waste critical minutes asking, is that friendly, can I shoot? The decision to strike is pre-approved for all targets that meet the machine's criteria.
This leads to a fascinating and, I think, a profound shift in discrimination logic. In the human domain, the focus is always friend versus foe to prevent fratricide. What does the machine logic shift to inside this autonomous zone?
The machine shifts to pure target versus non-target discrimination.
Target versus non-target.
The systems are no longer primarily consumed with the location of friendly forces. They don't have to be. Instead, they focus solely on identifying hostile military assets, tanks, armored personnel carriers, logistics trucks, enemy command and control nodes, and avoiding non-combatant civilian structures or populations that are pre-identified on the Do Not Strike list.
And how is that managed without human eyes on the target?
It relies entirely on continuous, comprehensive sensor fusion from adjacent and standoff systems. We're talking about automated input from, say, the combined arms motorized companies and the air maneuver platoons operating short of the BCL. They're feeding real-time intelligence into the zone. The systems are designed to identify target characteristics. Is that a T-90 tank?
Yeah.
Not necessarily wait for a human controller to approve that target set.
If the decision-making is purely automated and the space is that permissive, the payoff is obvious. Tempo advantage.
Massive tempo advantage. The Joint Force Air Component, the JFAC, gains the ability to execute interdiction immediately. There is zero coordination lag. If a target is identified moving inside that 30-kilometer zone and it matches the established hostile parameters, it is engaged within seconds.
Seconds.
The machine fights at the speed of data transfer, not at the speed of human dialogue. And that's the only way you can deliver the necessary volume of fire to overwhelm a near-peer opponent's armored echelons. #Tag40. Efficiency and the human capital crisis solution.
The gains in tempo and lethality from this geometry shift are, they're crystal clear, but the proposed doctrine is so compelling because it addresses a problem that military leaders, they rarely talk about publicly with this kind of clarity.
No, they don't.
And that's the human capital crisis. This autonomous zone isn't just about faster bombing, it's about solving a severe manpower shortage.
That is what makes this doctrinal paper so strategically astute. It acknowledges that the Army and the Air Force are currently heading toward a human capital cliff. They are struggling severely to retain and to produce the highly specialized personnel required to execute CAS safely in that traditional high-friction environment.
And this scarcity is focused on 3 highly trained, frankly, non-replaceable skill sets that are essential for detailed CAS integration. Let's talk about the scale of this pipeline problem.
The 3 critical specialists are: 1, Joint Terminal Attack Controllers, JTACs, the gold standard of fire controllers.
Yeah.
They have to maintain currency in incredibly complex environments, and they direct the final attack.
Okay.
2, Joint Fires Observers, JFOs. They're trained to call for and adjust non-organic fires. They often act as the eyes of the system for the JTAC. And 3, Forward Air Controllers Airborne, FACAs. These are highly qualified aviation officers who coordinate air support from above, often spending hours loitering in very complex and dangerous airspace.
And the training overhead for these specialists is enormous, isn't it?
It's resource intensive, and it takes years to achieve and then maintain proficiency. A qualified JTAC, for example, requires extensive training time, live fire currency exercises, complex controlled simulation time.
It's a huge investment.
It's a massive investment. The cost is measured not just in dollars, but in years of specialized development for one person. The pipeline is slow, and unfortunately, we are seeing a significant scarcity right now. The sources point to drawdowns in the JFO and FACA communities, and that's coupled with an overall retention crisis across the military.
That leads to the terrifying attrition risk in a high-intensity peer conflict. If we are fighting a peer, these highly identifiable fire coordinators, JTACs specifically, with their radios and lasers, they will be primary targets for electronic warfare, for counter-battery fire.
Absolutely. The expected attrition rates for these experts in a contested environment are projected to be extremely high. The existential threat is this. In a high-intensity conflict, you simply cannot replace a skilled current FACA or JTAC at the rate you would lose them.
You can't just mint new ones.
You cannot generate the required volume of new specialists fast enough to sustain the old CAS safety model across a massive front. It's impossible.
So if we can't train enough people to run the old doctrine safely, the new doctrine becomes required for survival. The autonomous zone effectively solves the problem by aligning doctrine with resources.
That's the strategic brilliance of it. The autonomous zone dramatically reduces the demand signal for these specific specialists in the deep fight. By shifting the bulk of joint fires into this modernized interdiction model, which, remember, requires 0 JTAC or FEAA input, we are aligning our operational capacity with our realistic human capital limitations.
So we stop trying to train for an impossible requirement.
And we change the battlefield requirements themselves.
This alignment also circles right back to the massive issue of inefficiency we identified earlier. Weaponeering for effect, not safety optimization.
Right. When that human safety constraint is removed by the BCL, the air component can finally load its aircraft intelligently. In the old push EAS system, we were forced to carry the surgical, expensive GBU-12 or GBU-38 because of the possibility of needing to avoid fratricide.
But inside the 30-kilometer autonomous zone where no friendly humans are allowed, that constraint it vanishes.
It vanishes completely. The aircraft are now weaponeered purely for their interdiction mission. They carry cheaper, mass-produced, higher-yield area effect weapons.
We're talking gravity bombs.
Specifically, things like gravity bombs, potentially cluster munitions, or large-scale precision glide weapons that are designed for wide-area destruction. We swap the costly scalpel for the affordable, effective sledgehammer. We are finally hitting mass targets with mass fire.
The sources quantify this optimization beautifully. What is the efficiency gain the JFI achieves by making this switch?
It's a complete game changer for logistics and for tempo, because of the need to use those low-yield precision weapons in the CAS environment. One interdiction effect on a large target might require 4 separate GBU-38s dropped across 4 separate passes.
4 planes or 4 passes for one target.
Right. But in the autonomous zone, using the correctly optimized area effect ordnance, one single interdiction sortie can achieve the effects that would have required 4 CAS sorties using the old precision constraints.
That's a 400% increase in sortie efficiency.
At a minimum. And that dramatically reduces fuel consumption, pilot exposure time, and the pressure on our very limited precision munition stockpiles.
The math is undeniable. I mean, the new geometry provides speed, it saves munitions, and it conserves our specialized human capital. But this is the military, and doctrine is often secondary to culture.
Often, yeah.
The source material points to a massive ingrained psychological obstacle that has to be overcome. They call it the A10 fallacy.
This is the emotional core of the resistance to this kind of change. The sources identify this deep-seated cultural bias that is pervasive within the Army, and it's born entirely of 2 decades of successful counterinsurgency warfare.
What fundamentally is this cultural bias rooted in? What is the A10 fallacy?
It's rooted in proximity and visual comfort. For so many field-grade officers, the majors, the lieutenant colonels, the colonels who run the tactical fight, their entire experience dictates that air support means the immediate visible presence of a manned aircraft.
Specifically the A10.
Specifically the iconic A-10 Thunderbolt II, performing a low, slow gun run to save pinned-down infantry. They measure operational safety and effectiveness by the aircraft's proximity and the sort of emotional comfort of seeing that immediate rescuer right there overhead.
It's the muscle memory of the desperate radio call. Troops in contact need immediate air, danger close.
That's the exact call.
But the A-10 is flying slow and low. It's visible. That emotional reassurance comes at a cost of vulnerability that is it's unacceptable in a pure conflict. It feels safer, but it's actually deadlier for the person flying it.
Exactly. This is the cultural trap. The A-10, or really any manned CAS platform, feels like a necessary lifeline because that's what we used for 2 decades when the enemy had no credible air defenses.
Right.
But when you're facing a peer, that manned asset trying to fly slow and low is a bullet magnet, a missile magnet. The Army's reliance on that immediate physical CA-spree presence is now an operational weakness, a huge one.
So doctrinal paper has to provide a powerful new reality check to the Army's command structure. It has to counter that emotional reliance on the image of the A-10.
And the rebuttal is sharp. It's necessary. And it is this. If a unit requires close air support in CAS to survive an attack, the operational plan has already failed. CAS is merely the emergency reaction to a tactical failure. It's the system of choice when an unexpected, overwhelming force has already reached your FLOT. In pure warfare, the moment the enemy is close enough to require CAs, you have likely already lost the battle of depth and maneuverability.
I see. So the reliance on CAS is actually a symptom of a larger, broken strategic plan, which means the new doctrine enforces a goal: shift from defense to depth.
The purpose of the autonomous zone is not to provide rescue. It is to provide massive, overwhelming destruction at depth. The new cultural objective has to be to destroy, delay, and disorganize the enemy formation before it ever reaches the FLOT, not to save the infantry after the fact.
You have to change the ingrained mindset.
From save me with CAS to kill them with interdiction.
And the 30-kilometer standoff enforced by the BCL essentially forces this cultural change. You don't have a choice.
It is the physical mechanism that enforces doctrinal prioritization. The 30-kilometer autonomous zone guarantees that the friendly infantry maneuvers in an area where the enemy echelons have already been chewed up by continuous high-tempo interdiction fires.
So the land component has to adapt its planning.
They must. They have to rely on the depth of the JFA's destructive fire. That 30 kilometers isn't just a distance on a map. It's the difference between friendly forces surviving first contact and strategically avoiding the full, unmitigated weight of a pure armored assault altogether. Hashtag 6. The role of uncrewed systems and actuarial risk.
So we've drawn the line with the PCL, we've enforced the cultural shift to interdiction, and we've solved the efficiency problem. Now we have to dive into who or what is actually fighting in that 30-kilometer space.
Right.
This is the domain of the machine, and specifically, the role of uncrewed systems and actuarial risk.
The sources are absolutely clear on this point. The autonomous zone is no-go terrain for human pilots. It is the primary maneuvering ground for uncrewed systems. UAS. This is where the bulk of our attrition is designed to occur, utilizing things like drone swarms, loyal wingmen, and other low-cost expendable airframes.
This high-threat, permissive environment, it demands a new philosophical view of military resources. We have to stop defining our platforms by their capability and start defining assets by risk logic.
This is a classification based purely on the accepted cost and the accepted risk associated with their potential loss. The sources propose 3 categories that are crucial for asset allocation.
What are they?
Number 1, survivable manned assets. These are your high-value platforms, your F-35s, heavy bombers, Apache helicopters. They represent an enormous investment in time, money, and human life.
Their loss is intolerable.
Politically and strategically intolerable. Therefore, they never cross the BCL. They operate at standoff ranges, firing their long-range munitions into the autonomous zone, but remaining safely in the human domain.
Okay, that makes sense. Number 2.
Consumable munitions. These are your rockets, your artillery shells, your missiles. They're designed for a single, one-way trip, and they're expected to be expended as a standard cost of the fight.
And the third category is the new one.
Number 3 is attritable, uncrewed systems. And this is the game changer for the autonomous zone. These are your UAS swarms, inexpensive fixed-wing aircraft, your loyal wingmen. They enter the zone with the intent to return, but with the explicit expectation of losses.
They are designed to be lost.
They are designed and budgeted to be attritable, that is, lost within very specific parameters.
The moment you accept the expectation of loss, you are free to be tactically aggressive.
Completely free.
And that brings us to the operational decision model, moving from a subjective command assessment to a calculated one. Actuarial risk versus subjective intuition.
The old way relied on the commander's subjective gut feeling, translating massive amounts of complex intelligence into a simple high, medium, or low risk assessment. That's too slow and it's too imprecise for autonomous operations.
So we have to shift.
We have to shift to the objective, data-driven actuarial risk model. This is a concept heavily detailed in the source material, and they reference work like the algorithmic sky.
So how does the machine actually perform the calculation? What specific data inputs are necessary to generate a precise probability of loss?
It requires integrating multiple layers of real-time intelligence at machine speed. Critical inputs include the electronic order of battle, the EOB, which is the dynamic, real-time map of all enemy electronic emitters, like their radars and communications nodes.
Okay.
The mission computer uses this EOB, combines it with terrain data, platform signature data, historical threat models, and it calculates a precise statistical probability of a loss for executing a specific mission profile. The output isn't a vague medium risk. It's a quantitative 15% probability of loss for this swarm to destroy that target.
That shifts the commander's job entirely. They go from being a tactical controller to a high-level strategic financial manager. They are now managing the threshold and budget.
Precisely. The commander sets a clear, quantifiable actuarial budget based on the desired strategic effect. For instance, I'm willing to lose 20% of my current drone fleet stock to successfully destroy the enemy's 3rd Echelon Artillery Battalion before midnight.
And that budget is pre-approved.
It's pre-approved for immediate execution by the autonomous systems.
But wait, this raises a huge logistical and, frankly, an accountability question. If a human commander pre-approves a 20% loss rate and the machine proceeds to lose 22% because of some unforeseen threat, how is command accountability managed? We're moving way past traditional human decision loops into the calculated expenditure of state assets.
That is the critical tension point of this entire doctrine, and the sources acknowledge it. Accountability shifts from real-time control to pre-mission parameter setting.
So you're accountable for the setup, not the execution.
Exactly. The commander is held accountable for setting the appropriate risk tolerance threshold and for verifying the inputs, the EOB accuracy, the threat models, the integrity of the do not strike list. If the machine operates within the approved 20% budget, the action is considered successful. even if 19% of the assets are lost. If the loss exceeds the budget, the system defaults to a higher level of human review, but the execution itself is automated and rapid.
A machine is trusted.
The machine is trusted to execute aggressively within its defined parameters.
And that budget approval is the key to enabling the highly aggressive execution inside the autonomous zone.
Absolutely. Uncrewed systems inside that BCL are free to operate aggressively. They don't need safety corridors. They saturate the airspace, often using tactics that would be suicidal for a manned platform, like a direct attack on integrated air defenses. They execute missions with maximum speed and minimum deviation because the cost of their loss has already been factored into the equation. This aggressive saturation is the final, essential stroke in solving the latency problem. It removes the need for real-time human approval for every single target engagement.
So the machine fights at machine speed.
Authorized by a machine-calculated and pre-approved budget. Hashtag Tag 7. Conclusion and final takeaway.
This has been a truly comprehensive look at a monumental doctrinal shift. I mean, from the historical failure of analog BAI and the unsustainable inefficiency of push CAS,
Right.
through the definition of the BCL, and culminating in this highly aggressive actuarial risk model, it paints a picture of a future battlefield that is faster, deadlier, and structurally optimized for survival against a peer enemy.
The central thesis of the sources is that our modern military has to internalize the prerequisite for survival, and that is the peace dividend of uncontested skies is gone. It's over. We cannot rely on the slow, permission-based architectures that define the global war on terror.
They just won't work.
To fight a peer, we must adopt an architecture that conserves our most valuable assets, our human specialists and our high-value manned platforms, while maximizing the lethality of our expendable machine assets.
And the doctrinal solution is the autonomous zone.
Yes, defined rigorously by the Battlefield Coordination Line, the BCL. The zone separates the human domain from the machine domain. This allows the land component to maneuver safely and focus on its immediate fight, while the air component executes continuous, high-tempo interdiction in the depth of the enemy formation, all without the catastrophic latency imposed by the need for detailed human coordination.
The necessity of this change is clearly tied right back to the high cost of human capital.
It is existential. The transition from push CAS to modernize interdiction is not just about making the Air Force more efficient. It is a prerequisite for survival. Because our resources, our highly specialized pilots, JTACs, and FACAs, are too scarce and too valuable to risk on slow, high-friction CAS missions in contested space. We must organize for a war that is defined by depth, by mass, and by autonomous lethality.
That brings us to our final thought. We've talked about actuarial risk, managing the loss of assets, and digital exhaust providing the targets. But the source material also mentions the technological backbone required to run a 30-kilometer autonomous kill box. Concepts like algorithmic deconfliction.
Right. So if you implement this zone, the machine is calculating the risk, it's identifying the targets, and then through algorithmic deconfliction, it's automatically negotiating airspace and fire trajectories in real time.
Negotiating with itself.
Yes. Imagine dozens of autonomous systems, drones, missiles, artillery shells, all arguing and negotiating their strike paths and their timing, all without a human voice in the loop.
So if the most critical survival-ensuring battle space action is managed entirely by algorithms that are operating within a pre-approved budget, what does this radical change mean for the foundational military concept of positive control?
That is a profound question this doctrine raises. Positive control relies on human agencies, radar operators, air traffic controllers, JTACs for positive tracking and direction. If the BCL defines a zone where machines are executing fires based on a preset actuarial budget entirely outside the human real-time decision loop.
What's left for the human commander?
What is the ultimate future role of the human commander? Their responsibility shifts from moment-to-moment control to setting the strategic parameters and then trusting the machine to spend the budget aggressively. It forces us to ask, are we ready for a system where human command exists only at the level of high-level parameter setting, and the tactical fight is run entirely by the algorithm?
That shift in trust.
That shift in trust is perhaps the greatest challenge of all.
A shift in trust that will define the future of joint warfare. Thank you for walking us through this monumental and truly necessary doctrinal transformation.